today we will try to understand the type set equations or equilibrium equations, and we will solve the problems which are based on this. If anyone has any query related to this, please let me know. Just raise your hand, I will clarify your doubts. Now here, if I am discussing this particular point, in this case, what we have, we are assuming each branch is something like this. In the previous case, what was our assumption? In case of the reduced incidence matrix, our assumption is that each branch will be something like this, and here is a current source. Here is a current source. That was the assumption, is right. And here is the current source, and this is represented as admittance. This is represented as a branch admittance, and this is nothing but current source. That is IS. This was the assumption. But in case of this type-set matrix or type-set equilibrium equations, in that particular case, we are assuming each branch consists of some impedance and some voltage source. If there is a current source, then those current sources should be converted into the equivalent voltage sources. That is the assumption here. Now, if we are applying the KVL to this loop, this is VK. VK is nothing but branch voltage. ZK is the impedance, branch impedance, and VSK is the voltage available in that particular branch. If we are applying the KVL to the upper loop, what is the K here? Here, if we are traveling in this direction, we are traveling from negative to positive, which is a plus VK. Plus VK. This plus VK, or we can find out this value of the VK. This plus VK is equal to, this is positive to negative, that is minus this IK into ZK. This is minus, it is IK into ZK. This is IK into ZK. And finally, we are traveling from positive to negative, that is minus VSK. This minus VSK, which is equal to 0, that is the KVL. And if we are simplifying this equation, we will get this equation. That is VK is equal to, we are shifting these values to the next side, then IK ZK, this is IK ZK, and plus this is VSK. That will be the equation in this particular case. Are you getting me? That is equation number 1. This is generalized equation. And if we are specializing this equation for the branch number 1, this V1 is equal to I1Z1 plus VS1, and this V2 is equal to I2Z2 into VS2, and this VB is equal to IBZB into VSB, which in general, if we are organizing these equations in the matrix form, how is the equation? This VB is nothing but branch voltages. It is a column matrix. How it is? Branch voltages means it is V1, V2, V3, V4, V5 and so on. It is equal to the number of branches and so on. This is the branch column matrix. This is column matrix related to that branch. ZB is nothing but impedance matrix. It is of order B into B. Just we have discussed about the YB in the last case. It is similar to that ZB. This IB is nothing but branch current, and plus it is VS is nothing but, this is the equation number 2. Means if we are generalizing this equation, then we will get this matrix. VB is equal to ZB into IB plus it is VS. We will simplify this equation. But we know that row-wise addition in the fundamental type-set matrix is VF into VB is equal to 0. This KVL equation, already we are aware of this. If we are putting this equation number 3 in equation number 2, look at how is the equation number 2. This is equation number 2. In this equation, if we are substituting the value of what? In this particular case, we are substituting the value of what? We are putting the value of putting equation number 2 in equation number 3. Yes, it is BF into VB. Which in place of VB, we are substituting that value. I will go back. Look at this value. This equation, this value we are putting in that equation. In place of VB, we are putting its value as ZB IB plus it is VS. In that case here, this VB is nothing but ZB IB plus VS. We are substituting this value. Then there is simple multiplication. This is BF into ZB into IB, which is here. Then it is a plus. This BF into VS, this term is here, which is equal to 0. That is equation number 4. But from the column-wise addition of the fundamental type-set matrix, we also know that, this IB is equal to BF transpose into IT, where IT is nothing but type-set current or loop current. This IB is equal to BF transpose. Now here, we are substituting this value of the IB here. This BF into ZB into IB, and in place of IB, we are substituting its value as BF transpose into IT, and we will simplify this equation number 4. So here, if we are putting the value of equation number 5 in equation number 4, this is BF into ZB And in place of IB, we are putting this value as BF transpose into IT plus it is BF into VS. If we are simplifying this complete equation, this is the first multiplication, this first multiplication plus BF into VS. Now here, what is this value? Now in place of this total value, we are assuming something. What is this value? We are assuming this as ZT. What is ZT? ZT is the tie-set impedance matrix. And how is the value of ZT? The ZT is nothing but BF into ZB into BF transpose is the value of ZT. This IT as it is, BF into VS as it is, and this is our final equation. How is the final equation? ZT into IT, which is equal to minus BF into VS, where ZT is the tie-set impedance matrix and its value is BF into ZB into BF transpose is that particular value. And this equation is nothing but equilibrium equation in case of this tie-set matrix.